Hello everyone, welcome to AI Anytime channel. In this video, we are going to work with Qdrant Vector Database. So we'll start with setting up Qdrant locally in our system using Docker container. So we are going to use Docker to set Qdrant in our local machine. Qdrant is an open source and of course self-hosted vector database that you can set it up locally. You can also use it for production level application as well. And we have many other vector databases, guys. We have if categorized into both open source and closed source. So we have Pinecone as a closed source vector database, which is very famous, that helps you, create indexes on Pinecone cloud. Okay, and then you can use it. Then we have a few others as well. So I'm not going to talk about the closed source vector database in this video. So if we talk about the open source and self-hosted vector databases, we have Weaviate, we have Qdrant, we have Milvus, we have in-memory vector stores like ChromaDB and FAS. These are all open source. That's what their licenses says, by the way. Now, we have worked with Weaviate in a few of our videos earlier. We have worked with FAS. We have worked with ChromaDB. The two vector databases that we haven't worked yet are Qdrant and Milvus. Okay, so we are going to set up Qdrant locally in this video, and we are going to build our first RAG. Okay, so this will be a series of videos, maybe two videos. In this one, we are going to set up locally, and then we'll retrieve some relevant documents or chunks with their score, and in the next video we'll use an LLM to use those chunks to form some kind of generated answer for you, or generated response, to build a question answering tool. Now to get started, how are we going to do this, guys? So let's first create a folder here, and I'm going to call this as, like, for example, Qdrant thing or something. Okay, now this is my folder, and inside this I'm going to first open this in terminal. Let's open this in terminal and open this in code dot. Okay, so that's what I'm gonna do. So let's first create a virtual environment and all here. Okay, so I will just minimize this. I'll make it bigger for you, full screen, and I'm going to create a virtual environment. So Python -mvenv.venv. That's how we create a virtual environment. There are other ways as well. You can use virtual env library as well to do it. Okay, so I'm going to do next is cd venv, cd scripts, and dot slash activate. You can execute everything in one line as well. I'm on PowerShell, guys. If you are using an Ubuntu machine, you have to do bin and then source activate. Now, let me just do a couple of cd dot more clear, and here I'm just going to install the dependencies that I need. So inside VS Code, let's create a requirement file here. So I'm just going to call it requirements txt. Let's create this requirements txt in this, and in this requirements txt, now we're going to do a few things here, guys. Okay, the first thing that we're going to do is install some requirements. So we're going to use LangChain because that's going to act as an orchestration framework. You have Haystack that is also compatible with Qdrant. You have Llama Index. I'm not sure about Llama Index, but probably you can check it out. I haven't worked with Qdrant plus Llama Index combination. I hope that there will be compatibility also with Llama Index. Now a LangChain, and here I'm going to use sentence transformer probably for some embeddings model. Let's see which embeddings model we can use. Probably we can use BGE, by the way, by Beijing AI Academy, right? One of the best performing open source embedding models right now, on the leaderboard. Now sentence transformers. Now we need torch, we need PyPDF, to use a PDF. We also need Qdrant client. Let me just come here and search for Qdrant client, and I will just come to their pip, and I will just copy this thingy here. Okay, Qdrant client. So let's copy. Excuse me, not here. Let me just plug off my charger a bit. Okay, now Qdrant client. So let's just paste, and these are the things that we need, guys. So what I'm going to do now is, hopefully, okay, so far, so let's first do a pip install thingy here. So pip install -r and requirements.txt, and I'm going to just hit enter. It will install those required dependencies for me. Now, how can we set up Qdrant? So there are multiple ways of setting up Qdrant. The first one is that you can set it up through Docker. Docker is a container technology if you are not aware, So I have covered Docker in my previous videos. You can watch it for more information on Docker. So you can set Qdrant through Docker. You can run this inside a Docker container on port 6333. And then you can also use it in memory, right? Locally, you can also do that on disk and in memory both. That's also you can do it. You can also set up Qdrant on cloud. They give you 1 GB till free. So you can also do that. So these are the options that you can create. If you also look at some other ways, if you are using some languages like Rust, for example, then you can also use Cargo, which is a Rust kind of a package manager where you can use Cargo to install and set up Qdrant in your machine. So I'll show you what I'm talking about. Now let's come here and say Qdrant Docker. Okay, and once you do that, you can see this is what we want to use, guys. We are going to use Docker Hub, which is the image is there, the Qdrant image on Docker Hub. Docker Hub is the official repository where you'll find all the listed images officially on Docker Hub. You can also use it Python or Ubuntu or Qdrant or SQL, whatever, right? So you can see it says vector similarity search engine with extended filtering support. It uses HNSW for indexing. By the way, we'll cover that later. Okay, I just saw it and it just clicked my mind. Then you have this is how you pull it, by the way, and this is how we're gonna pull. So if you don't have Docker installed, you can also use Qdrant client, to install it locally. You can have a look. They have high-level APIs that you can use it within Python as well. Now, I prefer this because this also helps me, this gives me luxury to also scale it up later on, if I need. Now, let's go back to terminal thingy, and you can see it's still doing something here. So what I'm going to do is I'm just going to open a new terminal. Anywhere I can open that, right? So that's let me just do it because I'm going to use Docker now. So to see if you don't have Docker installed, you can use Docker Desktop Installer on Windows, and you can install Docker through sudo install command on Linux distro, and you can have a look at that on their documentation. Here, what I'm going to do is I'm going to do Docker info. Now, once I do Docker info, what it will do, it will show me all the details about the Docker thingy that I have in my system. And you can look at that here, blah, blah, blah. I have versions and all. Okay, so it means I have Docker. Now, if you look at if I have any existing images, that's how you see it, guys. Docker images. You can see I have no images right now. If you also want to see if you have any images and if you are running anything that inside a container, then you can do Docker PS to see that. So if you do Docker PS, it will list you all the running containers. You can see I don't have anything. Now let's pull, the Docker the Qdrant image, okay, the Qdrant Docker image from Docker Hub, and you can look at the command here as well. But I remember the command, okay, so I have worked with it earlier. So Docker pull, and you can see it's suggesting me because I have worked with it earlier as well. So Docker pull Qdrant. So let's just pull it here now. It will take a bit of time. It's around 145 MB. So I have worked with it heavily, so I remember a few things. It will take a few minutes depending on your internet speed and the traffic. And once you get the image, you can just do Docker images to find out. We'll do that in a bit. Now, Qdrant has around 13K plus GitHub stars, so it's really good, by the way, if you compare with at least Chroma and Fast, which are like more in-memory vector stores. Qdrant, Milvus, and Weaviates are like vector databases. Okay. Now, if you look at here, I can just do Docker images. And once I do Docker images, you can see I got a new image called Qdrant, and it's 144 MB size. So it means I have Qdrant now and I can work with it. The next thing is, let's open this. Now I'll just close it here and I will go back to this terminal and I will tell you why. Because if you look at, let me just do, if you look at here in this folder, I want to create the volumes inside this folder only so I can explain it better. Now you can also you can create volumes in when you are creating the when you're running the Docker image inside a container, wherever you want to store the vectors, okay, all of your embeddings, right? You can you can store it here as well, so we can better track it when I'm explaining it, that how it's creating and if it's created the embedding successfully. Now, so we can just mount the volume over here. So let me just open in terminal here, and I'll just close this terminal again, and you can see now I am in this Qdrant thing. Let me just show you in VS Code. We don't have anything yet. Now, first thing is that let's run the image inside a container. So what I'm going to do is I'm going to do docker run, and you can see it's showing me that's how you can run it. It runs on 6333 port. Okay, so I'm going to do docker run -p, which is for port, and I'm just going to do 6333 and 6333, and the volume, you can see -v, which is for volume, and I'm just going to say, okay, this is what you're going to do. Like, dot means inside the current working directory. If you want to create this volume somewhere else on your disk in your system, you can give the full path. If you want to, the basically the relative path of it, if I'm not wrong, you have to give the path there. But I'm just going to do dot here, and let me just do this, and then just Qdrant, the way we store it, so storage Qdrant and /Qdrant. Okay, now this will help me run this image inside a Docker container, and I'm also on port 6333, and whenever I create the embeddings, all the volumes will be mounted in this directory. Okay, so let's just hit enter. Now, once I hit enter, you can see it says access web UI also. Now, you can go to that and we can have a look in a bit. Few things I will explain here, guys, which I feel is important for you to know. Okay, just okay. I don't know why my charging got okay. Anyway, now if you look at something called gRPC, right? It says Qdrant gRPC listening on 6334. Okay, in that case, what does gRPC means? We also have to talk about it when we are writing the code for creating the embeddings. Now, if you look at here, it says your image is now running. So let's try it out here. So what I'm going to do is I'm just going to do localhost 60. Yeah. Now, if you do that, it shows here title Qdrant vector search engine. Okay, it prints you something. Okay, this is not what we are interested in. But anyway, let's see if dashboard takes you anywhere. Okay, that's what they were saying. Now you can look at here. Locally, we are kind of setting up your like this Qdrant, like you do it in cloud. Like if you have used Pinecone, you will have their AC index starter pack or something. Okay, where they give you a free starter pack where you go and create your index and then you see it something. Right. Similarly, you can also see all of your collections over here as well. Now, it gives you here a console. It gives you here collections of your document, and if you click on this, you can expand this. Also we have a dark theme. Let's make it dark. Now you can see we are running it. So we are good with this now, guys. So let's create a file here. You can see I have few folders because we have mounted here. We have collections folder, and all of our vectors will get inside this collections folder. So there will be a subfolder that we'll create, and all of your embeddings will be inside that. Now in aliases, it will have a empty JSON file for your data. You can create some structures, schemas, and all. So let's ignore that for now. Now, what I'm going to do is I'm going to create an ingest.py file. Now imagine if you have a PDF, okay, you have multiple PDFs or a single PDF, whatever, right? First thing that you have to do, if you want to build a question answering chatbot or a chatbot or a search or a RAG kind of an implementation, for everything, you have to first create the embeddings, okay, of your data, store it somewhere, use some retrieval mechanism to retrieve based on the query that you are asking through semantic search or whatever. And then once you retrieve that, you give it to a large language model. That can be any large language model that will look at the retrieved responses and form a human like response. That's how it works, guys, end to end. Now here in ingest.py, now what I'm going to do is here I'm going to basically first write the code to create the embedding. So let's do that. So first thing I'm going to do is from LangChain, the vector store. We're going to use vector store of LangChain because that's where it's It has everything, Qdrant, Milvers, Pinecone, whatever you need. And here I'm gonna say Qdrant. So let's do it. Ah, I'm using Copilot. By the way, it's try to become little smart sometime, but it's okay. Now from LangChain vector stores import Qdrant. You can see it's also showing me fast. We're not gonna use that. We're going to use, we need an embedding model, guys. So which embedding model we can use in this case? So we have to talk about that. So let's use an embedding model. So let me just show you that which embedding model we can use. So we're going to use, let's use BGE embeddings. So I'm going to use BGE embeddings by BAI. If I'm not wrong, it's for Beijing AI Academy. Okay, that's the embedding model. One of the most well-performing embeddings model right now. Okay, that's what we're gonna use here in this case. So let's do that. So for this, what I'm gonna do is I'm gonna say from LangChain dot embeddings, and then you import BGE embed or Hugging Face BGE embeddings, not BGE. Hugging Face BGE, or I think it's, I don't know why it's not suggesting, but anyway, BGE embeddings. Okay, BGE embeddings. Now, this is fine. Now we have our embedding model. You can see it's also showing sentence transformer that we don't need because we are shifting to BGE now because it's performing good. Now we also need some PDF loader or something. So from LangChain dot document loaders, and then I'm gonna import PyPDF loader. That's what I'm gonna do here. So this is what we're gonna use, PyPDF loader, to handle the PDF, for extracting the text out of it and then giving it to an embedding model to create the embeddings of all the documents. Okay. Now PyPDF loader is done. We need some kind of splitter that will help on some defined units that can be on token or characters, whatever. Okay, so let's do that. So in this case, what I'm going to do is from langchain.textsplitter, import, and I'm going to do recursive. Ah, it's so bad. Okay, recursive character splitter. Okay, it's not characters, by the way, it's character text splitter. Okay, recursive character text splitter, fine. Now we are done with our imports. Now the first thing is we need a PDF file. So let's first define loader equals PyPDF loader, and inside that I'm going to pass my data name, which data we can use. Let me show you guys. So what I'm going to do here is in my downloads, I'm going to copy this thing here. Let me just copy it, and I'll close, and I'll come back on desktop and Qdrant thing, and I'm gonna paste here. Let's rename this as data. I'll tell you what this is. Okay, now this is GPT-4 technical paper. Okay, so let me just show you quickly here, and then you can see I'll just make it bigger for you. It's a GPT-4 technical report of having 100 pages inside it. So it has 100 pages. Now you have medical document, you have a legal document, you have insurance document, you have any document. You can use that here to create the retrieval first. Okay, so let's do that. Now we're gonna use GPT-4 technical report to build this. So let's just use the data here inside the code. So this will be data.pdf. Let's do that here. Now I do the data.pdf. Now this loads the data. Now it doesn't load the data, it currently holds the data. Now we're going to use loader.load to load it. Now loader.load load the data in this documents variable. Now once we have loaded it, we'll use the text splitter that we have imported above. So recursive character text splitter, and inside this I'm gonna pass a few things. The first is chunk size. Like for how many characters you want to chunk. Okay, create each chunk. So if you define as, like, for example, 500, so the first 500 characters will become one document. Okay, that's what it does. So chunk size, this becomes one chunk. Now chunk overlap, so you have something called chunk underscore overlap. So let's do that as well. Now in this case I'm going to keep 50. Now it depends, there's no uh thumbs rule, to do that. Okay, you can, this is really intuitive. You have to look at your data and then do it accordingly. Okay, now there's no rule of thumbs, by the way. I don't know why did I say thumbs rule or something. Okay, now text splitter, where you have chunk size 500 and chunk overlap 50. Now what I'm going to do is text, and this text are nothing but text splitter dot split. Let's split that document, by the way. Split documents, text splitter dot split documents. I don't know why it's not showing. I have to stop using GitHub Copilot. Documents. Now what we are doing here, guys, so far, jokes apart, by the way, you have loaded a PDF, okay, and you have defined some uh, rules to basically parse the data or create basically the chunking strategy. You have 500 chunk size for each chunk, and then there are 50 overlap, okay, and for the next chunk. Now if you look at text, we are splitting the text. Now text has everything. You can print the text 0 to find out the first in the list, okay, you can do that as well. Now we have to load the embedding model, so let's define that. Load the embedding model, okay, and here I'm going to use model name. So let's define the model name, and I'm going to use BGE as I said. So let's copy the thingy from here. Let's copy the path from BGE defined over here, by the way. Okay, now we have our model name, and what I'm going to do is I'm going to use some model quarks here. So let's do it. Wrong. And what do you want to use? Do you want to use CPU? Do you want to use GPU? Whatever. Okay, so let's do it. So I'm going to have device equals CPU here. This is what I'm going to have. So device CPU. This is my model quarks. If you have a GPU machine, you can leverage GPU as well if you have CUDA installed. Okay, now let's have encode quarks as well for some embedding normalization and some other features. We'll keep false here probably. So normalize underscore embeddings. Okay, now let's keep this as false. So this will be false, which is a boolean value. I don't know why I'm writing in a string here, so let me just do false. Okay, now we have encode quarks as well. So let's define the embeddings now. Hugging Face BGE embeddings, and inside this I'm just gonna call the above defined. Perfectly fine. That was a good rhyming, by the way. Model name equals model name, model quarks equals model quarks, and encode quarks equals encode quarks. Now this embeddings model, let's print the embeddings model, by the way. Okay, now to embedding model loaded or something like that. Okay, now this, so far we have our embeddings model. Now we have to basically use the vector, we create the vectors, right? So let's do it. So what I'm going to do is, we know that we are running our Qdrant on localhost. You can see this is the URL which showing you. Now you can also define your collection name here, by the way. So let's do it. So I'm going to do collection name equals GPT-4. Let's call it GPT collection. Okay, this is what our GPT Vector DB. Let's call it GPT DB. Okay. Now I have defined my URL and the collection name, which will go inside the collection folders that you see in the VS Code file explorer. Now what I'm going to do next here is, guys, we have URL, we have collection. So let's have a variable called Qdrant, and here I'm going to initialize Qdrant dot from documents. And you can see that we have imported Qdrant here in the first line, and that's what we're going to using here. So Qdrant dot from documents, and what I'm going to do here is, first is text. So let's do text. We have text that we have in line 12. That the text we are going to pass it to the embedding model first, and then it will create the embeddings and store it in this vector database. Now the next is embeddings. It is fine. The next is URL equals URL. For a little bit of interpretable, let's write URL equals URL. Then collection name. And here is the thing that I want to show you. It has something called gRPC. So if you don't know what gRPC is, it's a remote procedure call that was developed by Google, if I'm not wrong. That helps you, to build efficient and scalable distribution systems. It helps you, interact with different microservices, piece of code within a network. Okay, now if you really want to, if you have 20 millions of embeddings, now if you assume you have thousands of documents and you want to create, you have different documents, folders, and you think that you have hell lot of embedding that you are going to create, then this probably will not work, right? You need a efficient and scalable distributing system to handle those things, and that's where this kind of features comes in that Qdrant provides. That's called gRPC. It uses something called protobuf, that is a language agnostic way of defining the structure of data. So when you load, when this piece of code connects with that running Docker container, and when you interact with it, your microservices interact with that piece of code. When you retrieve something, protobuf is there. That's what gRPC provides in that case. So this is again really technical. I'm not going into those details right now, which is not that helpful in this case, but it's okay. You can read it on documentation and all. So prefer gRPC. Let's keep it false for now. If you make it true, then it automatically runs on 6334 on port, the gRPC APIs. Now, prefer gRPC, and then I just give collection name equals collection name. Okay, fantastic. Now, here we have a client that's called Qdrant that will take care of everything. Now that's it. Now let's just print that Qdrant index created, or like let's call it vector database created or something like that. Okay. Oh, it's okay. Now let's run this and see if we get any error, guys, here. Okay. So what I'm gonna do is I'm just going to run this. Okay. Let's open a new terminal. Blah blah blah. And in this new terminal, I'm just going to go inside cd venv and cd scripts and /activate couple of cd dot dot, couple of cd dot dot, and clean. And what I'm going to do now is I'm just going to do python ingest.py. Uh, It says from langchain dot embeddings, it says cannot import name hugging face BGE embedding. Let me see what wrong I'm doing. So I'm just going to search here BGE embedding langchain and BGE on hugging face. Let me just copy it. I really don't know if I have some typos or all, but it's fine. So let's just replace this thingy. Okay. I think I got it. You can look at this F here, right? There was a typo here, but it's fine. So let me just remove this thingy. And this will again become capital here. Hugging Face BGE embeddings. I think everything is good now. Let's try running it here, guys. Let's see if it still gives some error. So what it will do, guys, if it runs, it has to first download the model weights, the BGE model weights from Hugging Face, which will be around, if we combine all the files, the shape tensors and the bin file, it will be around 3-4 GBs, if I'm not wrong. I think it's doing something. Let's wait for it. I don't want to pause the video, guys. If you want to skip a video a bit, you can do. You can see it says embedding model loaded. Okay. It was surprising. Why did it say embedding model loaded? Oh, it didn't see a progress bar anywhere. But anyway, let's see what it does. Uh, it it should uh, it should download the model weights, shouldn't it? Let's see that. Okay. It will take a bit of time because it has 100 pages. If it's really creating the embeddings in that case, maybe we should have verbose or something to keep a track of it, the verbose or the logs wherever to see that's what's really happening now. But it is okay. You can see we have this line number 25, which has been successfully printed here. It means that till this it has ran. I mean, I didn't see it here in the terminal, and then we have this step which creates a collection name inside this folder collection that we'll see, and then it says Qdrant index created. Let's wait for it a few minutes and see if that works. Fine. Oh. Let's, by the way, look at the document. Let me make it bigger. Um, Let me pull up some key challenges, loss predictions, blah blah blah, capabilities. Maybe we can try this out. How does how well GPT performed, on the professional and academic exams, if that goes successful here. So let me just open a notepad, to write a question here. So in this notepad, what I'm gonna do is I'll make it little, oh, not save. Okay, and here I'm just going to write, let me just minimize this for a while. And here let's write how how will the GPT-4 performed on the professional and academic exams? This is the first question that we can ask. Okay. Our next question can be, let's see. Next question. Visual inputs they have. Let's try it out. GPT-4 has similar limitations than earlier GPT mode. Most importantly, still is not fully reliable. Okay, fine. What are some of the limitations? What are some of the limitations of GPT-4? These two questions will be enough, to ask. Okay, it seems that it's creating the embeddings for you because you have 100 pages and it will create the embeddings, and you can find out on that Qdrant index over there. Now let's wait for it a bit more, guys, to see. Now you can look at this collections here. Inside collections, I got a new folder that's called GPT DB, that our collection name. So it means this step has also been done. And if you look at inside this, you will look at segments. Now inside segments, if I show you, you will have all the files that has been listed, the embeddings, okay, inside the segments. Now let me just minimize that, and it's fine. I still wait for it. If I come here, Qdrant something, and now you can see that when I refresh the dashboard on which is running on 6333, our Qdrant inside a Docker container, and you can look at your GPT-4 DB. Now inside GPT-4 DB, that's what the beauty of Qdrant is. You don't have to pay money, to Pinecone or Web8 cloud services. You can do it locally as well. Even Qdrant provides you 1 GB free on cloud. But here, if you have enough infrastructure, you can set it up locally. Now you can look at all the chunks that has been created. As I said, it's very intuitive. You can look at the metadata, you can look at the page number, source, page content, and these are all your page content, by the way. You can look at all the page content that has been created here. You can also search, you can find similar by ID. This is your info, status is green. You can look at all the counts or whatever, okay, visualize, and all of those things can be done here. Now this is the beauty of it, guys, okay, to be honest. Now because it is self-hosted, you can host it yourself. Now let's go back to here. I'm still loading, but meanwhile let's write the code. Let's not waste our time here. And so what I'm gonna do is, let me just come out of this, and I'm going to create a file called app.py, and inside app.py now we're going to basically use the created embedding model and see if embeddings created vectors, and see if that retrieves the information or not. So from lang, let me just copy it from that only. You don't have to write, you just have to add one thing here. I just need these two things, so I'll just copy. Let me just copy it here, and what I'm going to do next is And what I'm going to do next is from after this, I need one more thing. I need Qdrant client. So from Qdrant and from Qdrant client, I just forgot Q here. So from Qdrant client, let's import Qdrant. It's not capital D, it should be small d. Qdrant client. Okay, now Qdrant client has been done. I, this is really surprising. Okay, now let me just open app.py. Oh, whew. Okay, Qdrant client, and here we need this as well, the entire model thing. So let's get the model again because the model will remain same. Okay, we'll use the same model to create the embedding for the query that we are going to ask. So we'll have one query and that will be given to this model. Now let's have the URL again. The URL going to be the same. So let's just do URL. Let's define the URL and also the collection name. So our collection name is also going to be the same. You can see it's GPT DB. Okay, so now we have copied the same code so far. Now what I'm going to do is I'm going to create a client here. So let's create a client. So I'm going to call it Qdrant client. I'm just going to use that here. Okay, this is wrong by the way. Okay, this is going to be that Qdrant client. Qdrant client, and here let's have Qdrant client. Okay, and inside this Qdrant client, the first thing that I'm going to do is URL equals URL. You can see the URL I'm passing, and again I can just do prefer gRPC, sorry, excuse me, equals false. So our client has been initiated here. Now we will use this client to basically use the semantic search or something in a bit. Now let's print the client here. So let me just print client to track if there is anything goes wrong. This is a better way of I do it, just to see. Prefer a collection name, embeddings, whatever. Right now, let's have a DB. So DB equals Qdrant. I'm just going to use the Qdrant from LangChain, and inside this Qdrant client equals client, and embeddings, and your collection name becomes collection name. Okay, fantastic. That's how we're gonna define the DB. Now we'll use this DB variable to basically query it. So let's first print the DB here as well. So just printing the DB, and I'm just again going to just give some line breaks or something like that. Okay. Now this is done. Now what I'm going to do after this is let's have a query here. So let's call a query, the query that we have kept in Notepad. So I'm just going to use what are the limitations of GPT-4 or something like that. Okay. Now this is my query. Now what I'm going to do is docs, and docs equal db dot similarity. I'm going to use a similarity RITY, I hope it's right. Similarity search with score. This is a function I'm going to use. It provides two functions. Similarity search only, that will only give you the relevant or similar chunks. You can also use similarity search with score. That also gives you some score. Now, similarity search with score. So let's use that score. And here I'm going to pass query equals blah blah. Query equals query and top k, like just the k number of document that you're going to search. So k equals to 5. Now this is my docs. What I'm going to do is for I in docs. Okay, in this I in docs, I'm going to write doc and score equals I. Okay, I, and after this I'll just use print. So let's print it. So print, and inside this print what I'm going to write is I'm going to write score, and the score is nothing but the score, and then I will have content. So content, we also need metadata and all, right? So let's have content. So here we'll get the page content and then get the metadata. So content becomes your doc dot page content. Okay, so you'll see page content, doc dot page content, and then we'll have our metadata. So let's do that. So metadata, excuse me, metadata, and then this metadata is nothing but doc dot metadata. So we are done with our code, guys. So what we are doing here, if you see, I'll just explain you quickly. We have imported all the libraries that we need. We have the same model, then we have the same way of initiating the client. We have a database that we have now DB variable, and we're just performing a semantic search on our query. Okay, this is query. Now it will retrieve some chunks. That's what we are expecting here. So let's see that. This is really surprising. I really don't know why did it get stuck here, but I do see the this has been populated. This has been populated, and you can see the vectors counts. Also, basically the vectors counts are increasing, so it's okay. You can see it's reflecting in real time, and that's what it takes some time, guys. Okay, so probably maybe I don't want to pause the video. You know, let's see. Uh, because if you saw the info last time, it was 28 or 24 vectors that was there. Now vectors count is the 512 vectors that we have now. Okay, the vectors count, and you can look at all the chunks over here that you can see. International conference or whatever, everything. The page content that we have over here. You can see the page content. Okay, this is your page content. Uh, Maybe you should have kept 1000 of the chunk uh, in our chunking, but it's okay. So let's wait for it. Embedding model loaded. Or let me just do one thing. I don't want you to be waiting. I'll pause the video here. I'll come back once it gets completed. Okay, so you can see that it says Qdrant index created. It took after once I paused the video, it took the other 1 minute, I think, and once it got done, you can see now if you see here on the dashboard, which is on 6333 double three port, 6333 by the way. Okay, I don't know why I'm making these stupid mistakes. And if you look at the info, now info, we have vectors count has been increased. We have segments count. If you know what does segment counts mean, okay, so you just HNSW, okay, approximate nearest neighbor to basically in retrieve, and when you go for the retrieval, like we look at here in collections. Let's go inside collections. If you look at the GPT DB, now inside this zero, you look at the segments, and in segments, you will have here 8 segments that we saw here. Now inside these segments, you'll find all of those serialized files. Okay, these are all serialized files. Now once you retrieve that, it will be deserialized. Okay, so uh, now going a little deeper, but now we have our vector embeddings created. Now what we can do is we can search. So now let's come back on VS Code, and inside this app.py we already have written the code. Hopefully everything works fine. Now what we're going to do is let's run app.py here. So Python app.py. Fantastic. Once we ran Python app.py, we can look at some of the print statements that we have made. Now let's look at a few things here, guys. Okay, I'll make it bigger for you. Now, if you look at what was our query was, okay, I'll show you here. Our query is what are some of the limitations of GPT-4? And we are expecting that this model, the BGE embeddings model, will retrieve some chunks from that created embeddings. Okay, so now let's see it. Not the model, by the way, guys, the semantic search algorithm. The model has been used to basically create the embeddings for query, and then just the semantic search algorithms will look at the relevant chunk, the similar chunk, and then return the similar documents to you. Now if you look at the first one, it says limitations. Despite its capabilities, GPT-4 has similar limitations as earlier GPT models. Most importantly, it is still not fully reliable. It hallucinates, blah blah blah, right? So it gives you this, then it has. So I have some other 4 relevant chunks right here that we have, but this is having the highest score, and you can see this is having the lowest score over here. Now there are a lot of things that you can do here. Okay, let's ask first the second questions as well and see if that works. Okay. We're going to change the query here in VS Code. Let's change it. We should have done this in a Jupyter notebooks, but anyway, we can do that in upcoming videos. But let's see. Now I change the Python this question now. Okay, the query. Now you have this retrieved chunk, and you can see we are getting good result, by the way. I can assure you that. Now you said GPT-4 performance on academic and professional exams. In each case, we simulate whatever, right? So, and I think we have to do better. We have to do better chunking. Okay, on chunking strategy. So if there are few things that you should consider, if your results are not in the right order, if you think that okay, my contexts are in middle, that you should look at some re-ranking approaches to re-rank some of these chunks and then give it to a large language model. Now so far, if you are a beginner, we have retrieved the chunks, but this is not the result that you will give it to end user. You have to pass this context with your prompts to a large language model. That's the upcoming video, the part 2 of this series. And then you will see that okay, how a human like response has formed, okay, a better response has formed, and then we can use a streamlit or a gradio or a chainlit application to basically have a chatbot. So I hope you learned what we did in this video, guys. Again, I will give you a very high level walkthrough. That we first have a file called ingest.py where we have set it up all our code that creates the loads the data, which is a PDF file, extract the text, use a embedding model to create the embeddings, and then store those embeddings in already running vector database inside a Docker container on this port. Now after that, once that has been done, after 5 minutes, we then load the same model for creating the embedding of our query that we have, this query, and then we're also setting up our Qdrant client that's already running, and then just do similarity search with score. That's what we have done so far, guys, in this video. Now this is really an essential steps, but in the next video we'll do a couple of other steps like re-ranking, how to rank the relevant chunks, because most of the time LLM struggles with the middle chunks. It only looks at the first and the last chunks. So we'll look at all those techniques, and then we'll build a QA chatbot using Qdrant or Haystack, LangChain, or whatever. We'll see that. We're going to use an open source model or probably a closed source also. I hope you learned something in this video, guys. If you have any thoughts, feedbacks, please let me know. If you have any queries, you can also reach out to me through my social media channels, and if you can also comment in the comment section below. Now, the code will be available on the AI Anytime's GitHub repository. I'll give the link in the description. So if you haven't subscribed the channel yet, please do subscribe, and if please share the video and channel with your friends and peers. Thank you so much for watching. See you in the next one.